Bismillahirrahmanirrahim. Welcome to the first part of the 21 lecture of the statistics and probability theory. In previous lectures, we have studied normal distribution. Normal is a continuous probability distribution. We have studied its properties, its features, and we have seen the curve of the normal distribution, which was bell shaped, and we have seen the probability density function of the normal distribution and how to convert the random variable into standard normal variable, which has the mean of 0 and standard deviation of 1, and then how to use the area table to find out the probability uh, between mean and some specific point of the random variable by using the standard normal area table, and how to use the reverse use of that particular table to find out the value of the random variable, and then how to find out the value of the x, unknown value of the x, by using the standard normal variable set. Topic of today's lecture is simple linear regression and correlation. Simple linear regression. The dictionary meaning of regression is the act of returning or going back. The dictionary meaning of regression is the act of returning or going back. First used by Francis Galton in 1877. Regression is the statistical tool with the help of which we are in a position to estimate or predict the unknown values of one variable from the known values of the another variable. Remember that one variable is unknown and the other one is known. A regression model is a mathematical equation that describes the relationship between two or more variables. In this lecture, we will concentrate on the two variable model, which we call the simple linear regression. A simple regression model includes only two variables, one independent and one dependent. The variable which is known is independent and which is unknown is dependent. Or you can say it random variable too. And this independent variable is also called fixed variable. The dependent variable is one being explained, and the independent variable is the one used to explain the variation in the dependent variable. Scatter diagram. To find a relationship between the set of paired observations x and y, let's suppose we plot their corresponding values on the graph, taking one of the variables along the x-axis and the other variable along the y-axis. A scatter plot is something like this. We take one variable on the x-axis and the other variable on the y-axis. Let's suppose here we take the variable y and at the y-axis, and here we take the variable x at the x-axis. The very first value is suppose x1 and y1 of the random variable. It would be somewhere here, and I change the color. So somewhere here, and this is the value of the x, and this is the value of the y. So this is the point x1 and y1. Here we will have the value x1 and here y1. Similarly, we can plot the or mark the other points as well. So this one is called the scatter diagram. And when we marked all the points on the axis, something like this would be the behavior of the data points. Let's suppose if we have height on y-axis and diameter on x-axis. So these are all the data points and this is the scatter plot. So these are the data points and what we will do, we will fit a trend line or a line of regression to find out the behavior of the data points. As you can see, all these are the data points. These are all data points and this black line passing through these points is the line which is capturing the behavior of the data points, or you can say it trend line as well, as we are studying the simple linear regression. So it would be the linear relationship between the two variables and the line of regression would be a straight line. If we have the data points in this way, something like this, so if we draw a line of regression, it would be something like this. So here it is the increasing trend and now here this is the decreasing trend. So this is the way to capture the behavior of the data points by using the trend line, and this is the line of regression. So a reasonable form of a relationship between the response y and the regressor x is the linear relationship. Remember here this y is the dependent variable we have assuming, and this x is the independent variable. And we have discussed in this slide that this is the line of regression, but how would we find out this line of regression? For this, we will use the simple linear regression, and this is the simple linear regression here. Y is the response variable, or you can say the random variable, or you can say the regressant, or you can say the predictant as well. And this is the variable which is the random, and this x is the non-random variable, or you can say it fixed variable, or you can also name it as the regressor or predictor as well. So they have the linear relationship y is equal to b naught plus b1 into x1, or you can say xi as well, as we have only one variable here. So this is the independent variable, this is the coefficient, and this is the constant. This y is dependent variable. This constant is basically the intercept, as if we plot this equation, it would be the straight line. This b1 is the slope. So this is the intercept. And this one is the slope. Now, if we plot this regression line, if we draw this regression line on the scatter plot, which contains the data points, like these are the data points, and this one is the uh, regression line. So we will plot this particular line on this scatter plot, and this model will call deterministic model, as we can determine the random variable y on the basis of this variable x. But what's the problem is, as you can see, this line is passing through these data points, but this line is not capturing the all data points. Like this point is exactly on the regression line, as you can see, but there is a difference between this point and line, also between this line and this point, also between this point and line, and this. So not all data points are on the regression line. So there is some error, as you can say that you are saying that this x is used to determine this y, but this x is not exactly explaining the whole variation in y, because there are some other factors too which are affecting this relationship. Let's suppose we have the y, and this variable y is the income. We have some intercept, which is b0, plus we have slope b1, and this is x, which we are using to determine y. So let's suppose this is the income and this is the experience, number of years which the employee have worked. So what we are doing, we are basically determining the income on the basis of the experience of the employee. But this is not the only factor which help us to determine the income. There are other factors too, like the qualification of the employee, the health condition of the employee, the working hours of the employee, and so many more. So there are many factors which are left, and we can't use them to determine the variable y, that somehow we don't have, maybe we don't have data on them or some other factors. So what we will do, we will use the simple linear regression model in this way, that we introduce this term epsilon, which we call the random error component. And this random error component is basically the capturing the other factors which are affecting the variable y, or which are affecting in the determination of the variable y, and this x is not enough to determine all the variation in the y. So basically we introduce the error term. So this dependent variable, this is the population y-intercept, and this is population slope coefficient. This is independent variable. All this is linear component, and this one is the random error component. So this is basically these are the errors, difference between the line and the data points, and all these differences are in this random component. These are some previous concepts about the straight line. If you have the line y is equal to beta naught plus beta 1 xi, so here we have beta naught is equal to 40 and beta 1 is equal to 0. So as beta naught is the intercept, so starting point would be 40, and as slope is used to find out the to determine the inclination of the straight line, so beta 1 as slope is 0, so this would be the horizontal line. Here we have beta naught is equal to 0, so the starting point would be 0, and beta 1 is equal to 0.8, so this is the level of inclination. And here we have beta naught is equal to 40, so this one is the starting point, and beta 1 is equal to 0.8, so this is the inclination. So these are some previous concepts which you all are already familiar. Here we have included it just for the sake of the revision. So this one is the simple linear regression model, and this one is the non-deterministic model. Here this model was the deterministic model, as error term is not present here, but in this case this is the non-deterministic model. This error term is normally distributed with mean 0 and the constant variance sigma square, and there is no serial correlation, no correlation between the consecutive period error terms. That is, if you find out that correlation between epsilon 1 and epsilon 2, it would be equal to 0.